Hey guys, welcome back. In this, we will be trying to solve the problem of the day of 2nd November, that is max DAG edges. Okay, so basically, you'll be given a directed acyclic graph with V vertices. Okay, you'll also be given an array called edges. So inside this array edges, you'll have pairs of U and V. So basically, a pair UV says that you have an edge from U to V. All right. You must find out the maximum amount of edges you can add apart from the edges available such that a cycle would not be made inside the DAG. Okay. Now, this is a very easy question to solve. If you think about the normal approach, let's move on to the whiteboard. If you think about the normal approach, one might think that you might have to, manually add edges and check if a cycle is being formed or not, but it's actually easy. All right. So let's see with the first example how it works. So you have three vertices which are available. All right. So 0, 1, 2. All right. So you have 0, you have 1, and you have 2. Okay. Uh, don't mind my handwriting. I don't have my vacuum tablet with me right now. Anyways, you have an edge from 0 to 1. Straightforward. You have an edge from 1 to 2. Okay. Now, how many more edges can I add such that a cycle is not made? All right, such that a cycle is not made. Now, we can add 0 to 2 as well, right? If I do this, a cycle is not made. So you can add one extra edge. Apart from this, if you try to add any more edges, a cycle will be made. All right, so now that's not valid. So we can add one extra edge. Similarly, in the next example as well, you can work it out for your own and you can see that it works, right? The output is right. So how can we solve this? Now, as I said earlier, if you try to go through the manual route, that is to go through your DAG and manually add edges till cycle is seen or made, it can actually be a headache to solve this. There's a much easier way, all right? If you guys remember, the maximum number of edges possible in a DAG is V into V minus 1 by 2. All right, you have a formula. The maximum number of edges in a DAG is V into V minus 1 by 2. Okay, if your edges will exceed this value, a cycle will be made for sure. Okay, so we can just use this formula to find out the amount of extra edges to add. See, if you have 3 as the amount of vertices, if you apply it in this formula, you will get 3 into 2 divided by 2. Okay, so your answer will be 3 itself. All right, but here's the thing, this is the maximum amount of edges you can have. They already gave you an array edges with 2 edges inside of it. So how many extra edges can you add? This minus the amount of edges given to them. So the answer is 1. Right, as simple as that. You can also apply it to the next example. Your V is 4. So if you apply the formula, you will get 4 into 3 divided by 2. Answer will be 6, right? So in total, you have 6 edges. They already gave you a graph with 4 edges. So how many extra edges can you add? 6 minus 4, 2. That's basically how you solve this. It's that simple. All right, so now let's try to code the solution out. Okay, let's code this out. It's pretty straightforward. So all I have to do is return V into V minus 1 divided by 2, right? As simple as this, minus the length of edges. Okay, now this entire thing will be a floating value since we are doing the division operation. So we'll just wrap it with int as well. All right, this should be capital. All right, let's see if this works now. There you go, it works. Let's submit. All right, so that's how you solve this problem. If you have any doubts, do leave them in the comment section down below, and I'll see you in the next video. Goodbye.